Good day, everyone. Our topic for today is Module 15, General Theory of Relativity, and this will be followed by how we know we live in an expanding universe. So, let's get started. So, before we discuss the main topic, here the focuses on Einstein's General Theory of Relativity. The first one is state Albert Einstein's general theory of relativity and its postulate. The number 2 explain the consequences of the postulate of general relativity, and number 3 give example where general theory of relativity was applied. So, let's start our topic or discussion on general theory of relativity by comparing kung ano ang nagagawa ng bigat natin if we try to rest on our bed. So, imagine, we are going to sleep dahil na oras na nga ng pagtulog. Siyempre, saan ba tayo pupunta sa bed? Like the image na nakikita nyo dahil sa taglay na lambot ng kama, mas pipiliin natin na mahiga dito. So, our weight or ang ating mga timbang ay nagpupush sa bed downward. Sinasabi dito na imagine a soft bed where lay your back and relax, but because of its softness, it depresses as you jump on it to lay down. Why? Because your weight pushed the bed downward. For example, this is likewise how Albert Einstein explained his theory on how space can be affected by the mass of an object. He said that when a mass is placed in space, the space will curve to the Sinasabi ni Albert Einstein na kapag ang mass daw ay na sa space, the space will get curved. Example, ito yung space. Tapos ito yung mass. Tapos pag ginanon, tapos kapag ang mass ay sa space, nagaganon. Kaya yung sinasabi niya ng curve. Kaya nagko-curve. The theory of spatial relativity and general theory of relativity are interrelated to another. Ang theory ng theory of special relativity at general relativity ay may kaugnayan sa isa't isa. Both are usually is a study of cosmology and astronomy where space, time, gravity, and force of nature are the focus. Pareha silang may kapaki-pakinabang sa pag-aaral ng kosmolohiya or cosmology at astronomiya kung saan ang espasyo ng lugar, gravity, and forces for nature are the focus. Yun yung pinaka-focus nila. In the preview lesson, you have learned about Albert Einstein and the two postulates under spatial relativity. So, the theory of Albert Einstein na tatalakayin natin ay maikukumpara natin dito sa kama nating hinihigaan. So, let us review the two postulates, especially relativity theory, the relativity postulate. So, ang unang postulate ay ang relativity postulate. Ayon dito, all law of physics is the same in all inertia frame. So, kapag nakaupo ka man o nakatayo sa loob ng eroplano, the law of physics remain the same. The law of physics is the same in all inertia reference frame. Inertia reference frame mean that the object is at rest and remain at rest. Kapag daw isang bagay ay yung walang force na nagaganap, wala natin siyang rest. Para mas malino kung bakit pareho ang law of physics sa postulate number 1, let's imagine ourselves if we have ever been in an airplane as a passenger. So, yung nakasakay kayang eroplano, so imagine yourself taking a plane to a destination. So, usually before the plane take off o bago mag-start yung eroplano, bago siya lumipad, we go to the comfort room to do our things before the plane take off, diba? Parang naman din tayo nag-CCR, yung parang, yung halimbawa kung yung sinong gusto mga mag-CR, yung may babaihi, ganun. Hindi pa po lumilipad ang aeroplano, no? So, you can walk like walking outside the plane, but kapag ang aeroplano ay lumipad, halimbawa kapag ang aeroplano ay lumipad na, you need to put your seatbelt for your safety. Kasi, maaari kang ma-aksidente The second postulate is state that the speed of light in vacuum it is the same for all observer regardless of its source. Pangalawang postulate ay nasasabi na ang bilis ng liwanag sa vacuum ay pareho para sa lahat. At ito ay may bilis ng 300 million meter per second. It just tell that when it's come to light, na kapag galing ito sa liwanag, speed it always constant taking into consideration. Na ang speed ay always, yung walang katapusan, is constant taking into consideration that is vacuum or empty space because it will be different when light passes into the different medium. Ang bilis nito ay palaging pareho para sa lahat ng mga taga-masin. Ano man ang pinagmulan nito? Noong alam natin na ang bilis ng liwanag ay hindi nagbabago kapag ito ay dumaan sa iba't ibang medium. Especially in it involve only in a situation where the inertial frame of reference is not accelerating. In this case, only time and distance change. Na in this case nga ay time at distance lang ang nagbabago and known to be as time dilation and length contraction.
General theory of relativity was formulated by Albert Einstein in 1915 when he found out that mass causes space to curve and space causes mass to move. Na-formulate ni Albert Einstein ang general theory of relativity noong nalaman niya na nagkakos ang mass ng curve sa space at ang space naman ang nagkakos para mag-move ang mga mass. In space, massive objects like stars, planets, and black holes possess gravitational field which will create curvature in space-time. Yung mga massive object like stars, planet, and black holes, sila yung nagkikreate ng curvature sa space-time. Yung mga curvature na yon ang nagpapagalaw sa object sa space-time. This theory is only applied for those that have a very large mass. There are phenomena which could support that there is warping happening in space-time due to the gravity exerted by a massive object. Consequences of general relativity. Ang unang consequences of general relativity ay ang shifting of Mercury's orbit. Mercury revolves around the Sun in an elliptical manner. Since Mercury is the first planet and nearest to the Sun, it was assumed that the Sun's gravitational field is the reason why there is a precession change in the other orientation of the rotational axis and perturbation disturbance in the regular elliptical movement of Mercury. Sa diagram, makikita natin ang precession ng Mercury's orbit at yung mga point na malapit sa Sun ay yung perihelion. Kung makikita natin yung orbit ng Mercury, ang ellipse ay pumapalibot sa araw. Gravitational bending of light. Since the strong gravitational field of a massive object causes distortion in this space, the light that travels in that region will follow its curve path resulting to bending of light. An example of which is the light emitted by a star and the Sun that is so massive causing the light to bend slightly. Dahil nga sa massive objects gaya ng Sun na nagkakameron ng curvature sa space-time. Maski ang light ay sumusunod sa curvature ng space-time. Gaya ng nakikita natin sa diagram, may dalawang stars. Yung isa ayun yung actual na stars. Talaga, pero dahil sa bending of light, ang na-observe nating star ay yung isang star. So, ibang direction yung nakikita nating star at hindi yun yung actual na star.
Black hole. Ang black hole ay isa sa yugto ng buhay ng mga bituin. Ito ay walang sukat, volume, at may hindi tiyak na density na kilala sa singularity. Ito ay meron ding hangganan na tinatawag ding event horizon, kung saan ang mga nangyayari sa loob ng hangganan ay walang epekto sa labas. Kaya naman, ang pagkakaroon ng malakas na grabitan nito ang dahilan kung bakit ang liwanag ay hindi nakakalabas kahit na ang radio wave signal. Gravita. Dito naman, sinasabing kapag bumilis ang napakalaking bagay, lilikha ito ng gravitational wave. Ang gravitational wave ay any disturbance sa coordination ng space-time na dala ng napakalaking acceleration ng isang bagay. When this massive object moves, it will change the curve in space-time, producing a ray fall. That's called gravitational wave. Gravitational redshift. Dito naman ang oras daw ay bumabagal kapag ang isang bagay ay gumalaw patungo sa isang lugar na may mataas na gravitational field tulad ng sa black hole. Kagaya rin ito ng liwanag na lumagpas at nagkaroon ng pattern pakurba sa space-time tapos ang liwanag ay nag-bend. Ang liwanag ay tinatawag na electromagnetic spectrum na mayroong iba't ibang properties kaya nagkaroon ng trough, crest, wavelength at frequency. Kapag ang liwanag ay gumalaw against the gravitational field, ang oras ay bumabagal pababa at sa paggalaw nito paibaba, ito ay nagkakaroon ng pagbabago sa wavelength at frequency of the light wave. So, when it is undergoing redshift, the wavelength, which is the distance between two waves, become longer. Ang frequency ay nagdi-decrease. Ibig sabihin, humahaba ang distansya between two waves na tinatawag na wavelength at ang frequency ay nagdi-decrease. Dahil sa electromagnetic sunlight, the light waves undergoes increasing wavelength. When the wavelength increase, makikita natin na lumalayo ang bawat distansya ng bawat wave sa isa't isa. And again, frequency decrease.